Hello guys, welcome back to my YouTube channel. This is Justin Bibelan aka Organism 118, and today I will be discussing to you topics in environmental science, which is entitled nutrient cycle, and the other one I will be discussing about biodiversity and biological evolution. Okay, but for today I will be discussing to you five nutrient cycles. Okay, what happens to matter in an ecosystem? Okay, matter in the form of nutrients like, for example, you have water, carbon, nitrogen. These are the nutrients that I'm talking about. You have also phosphorus and sulfur. Okay, they are actually cycles within and among ecosystems. And because of this, human activities could possibly alter this chemical cycle. So let's talk about it now. Nutrient cycle within and among ecosystems. So the elements and compounds that make up nutrients move continually through air, water, soil, rock, and living organisms within the ecosystem as well as in the biosphere. This is what we call the nutrient cycles or biogeochemical cycles. Okay, so basically it's just a cycle or it's a movement of matter through air, water, soil, rock, and living organisms within the ecosystems. And these cycles, which are driven directly or indirectly by the incoming solar energy and by the Earth's gravity, include the hydrologic cycle or the water cycle. We have the carbon, the nitrogen, the phosphorus, and the sulfur cycle. For today, I will be talking about to you first the water cycle or what we call the hydrologic cycle. Okay, water or is an amazing substance, okay, that is necessary for life on the earth. And the hydrologic cycle or water cycle, it actually collects, purifies, and distributes the earth's fixed supply of water. The sun powers the water cycle. Incoming solar energy causes the evaporation. So there are actually three processes that involves in the water cycle. We have the evaporation, which the sun powers the water cycle, and the incoming solar energy causes the evaporation or the conversion of water from liquid to water vapor. And from the Earth's oceans, lakes, rivers, soil, and plants. And these water vapors rises into the atmosphere where it undergoes condensation. That means the water vapor that rises into the atmosphere, it condenses into droplets, and then that's what we meant by it changes into water vapor to water liquid now, or what we call the water droplets. And then the gravity draws the water back to the earth of what we call the precipitation. Okay, so the gravity draws the water back to the earth's surface by precipitation. So the precipitation can be a rain, it can be a snow, a sleet, or a dew. Okay, so over land, about 90% of the water that reaches the atmosphere evaporates from the surfaces of plants through the process called transpiration and from the soil. Okay, so the plants now they have also their water there that can also be evaporates because your plant can also undergo what we call transpiration. Okay, so most precipitation falling on terrestrial ecosystems becomes a surface runoff. Okay, from terrestrial ecosystem, so most of this can becomes a surface runoff. Okay, and this water flows into streams, rivers, or wetlands or oceans from which it can evaporate to repeat the cycle. And some precipitation seeps into the upper layers of soils where it is used by plants, and some evaporates from the soils back into the atmosphere, and some precipitation also sinks through the soil into the ground layers where the ground layers of rocks and sand and gravel. Then that is what we call the groundwater. That is what we call the aquifers. Okay, so where it is stored as a groundwater, and some precipitation is converted to ice that is actually stored in glaciers. Okay, so that's it, or ice and snow. Okay, so usually for long periods of time, because water is a good dissolving in many different compounds, it can easily be polluted. Okay, throughout the hydrologic cycle, many natural resources purify water by drawing pollutants out of it. Thus, the hydrologic cycle can be viewed as a cycle of natural renewal of water quality and an important and free ecosystems service. Okay, so um, because of this, there is also what we call the alteration of the hydrologic cycle because of human activities. So, how does humans alter the water cycle? Okay, so humans alter the water cycle in three major ways. First is that we humans withdraw fresh water from rivers, lakes, and aquifers, and sometimes at a rate faster than the natural processes can replace it. Okay? As a result, some aquifers are being depleted and some rivers no longer flow to the ocean. Okay, and second one is that we clear vegetation from land for agriculture, mining, and road building and other activities and cover much of the land with buildings, concrete, and asphalt. In this case, this increases the runoff and reduces infiltration that would normally recharge ground water supplies. And the third one is we drain and fill wetlands for farming and urban development. Left undisturbed, wetlands provide the ecosystem service of flood control, acting like sponges to absorb and hold overflows of water from drenching rains of rapidly melting snow. Okay, so without this wetlands and without all of this without drainage and also wetlands, okay, so we will be able to control the flood or if there's an incoming heavy rains, and of course it will result to floods in areas. Okay, so that will we will have no control of it if we are going to uh, drain and fill our wetlands, and that is for farming and of course for urban development. Okay, so those are the three ways that we can actually alter the hydrologic cycle. The next nutrient cycle is the carbon cycle. So carbon is actually the basic building block of the carbohydrates, fats, proteins, DNA, and other organic compounds necessary for life. Various compounds of carbon circulate through the biosphere, the atmosphere, and parts of the hydrosphere in the form of a carbon cycle. Okay, so the key component of the carbon cycle is the carbon dioxide, which actually makes up our atmosphere about a 0.040% of the volume of the Earth's atmosphere, and also some of the carbon dioxide are actually dissolved in water. Carbon dioxide affects the atmosphere, the temperature of the Earth's atmosphere through the what we call the greenhouse effect, and thus plays a major role in determining the Earth's climate. So we already discussed about the global climate change and also global warming. I mean about the greenhouse gases, and one of the greenhouse gases is the carbon dioxide, since it actually reflects or it actually absorbs the heat that actually reflected back into the universe, but it actually absorbs the heat and it reflects back into the Earth's atmosphere. Okay, that's why it hits the Earth's atmosphere. That can also cause global warming. Okay, so carbon is cycled through the biosphere by the combination of photosynthesis. Okay, so we already knew about photosynthesis. Okay, so carbon dioxide is actually absorbed by the plants. Okay, which actually when there is a ultraviolet rays that is coming from the sun, so photosynthesis happens by plants. Okay, so by producers, which actually I also give you last topic about the a reaction about photosynthesis, where if it absorbs uh, it actually absorbs carbon dioxide. Thus, it removes K, and also uh, it actually releases oxygen into the atmosphere. So it absorbs carbon dioxide and therefore releases oxygen back into the atmosphere. And this oxygen is also being inhaled or needed by the living organisms like animals and also we humans, and so that we can have our process, which is actually known as the aerobic respiration. Okay, so aerobic respiration, we use up oxygen, and therefore we are going and we exhale carbon dioxide. And this carbon dioxide now will actually in turn be used also by the plants for photosynthesis, and the cycle continues. Okay, so carbon is cycled to the biosphere by a combination of photosynthesis by producers, which remove carbon dioxide from the air and water, and aerobic respiration by producers, consumers, and decomposers, which adds carbon dioxide in the atmosphere. So typically, carbon dioxide remains in the atmosphere for 100 years or more. In water, decomposers release carbon that can be stored as insoluble carbonates in bottom sediments or in limestone or in sediments, okay, in a form of a limestone, okay. So some carbons are actually stored there, and every living on the earth is part of the natural carbon cycle. Over millions of years, the carbon in deeply buried deposits of dead plant matter and algae were converted by high pressure from the weight of overlaying sediments and heat released during the decomposition of dead matter into carbon-containing fossil fuels such as coal, oil, and natural gas. And in only a few hundred years, we have extracted and burned huge quantities of fossil fuels that took millions of years to form, and added large quantities of carbon dioxide back to the atmosphere. Okay, so those that are actually formed by those dead animals and dead matters are actually uh, formed into a fossil fuels. Okay, and we use up fossil fuels into large amount by burning it. Okay, so that we can run factories and industries, and therefore we are releasing thereby large quantities of carbon dioxide to the atmosphere. And because of this, we can alter the carbon cycle. Okay, so carbon cycle can be altered when we extracted and burned huge quantities of the fossil fuels. Okay, and another way that we can alter the cycle is by clearing carbon-absorbing vegetation from many forests. Okay, like for example, deforestation, and especially in the tropical forests, which have a large variety of trees there. And of course, if we cannot, if we destroy or we deforested the area faster than the nature can actually grows it back, then therefore we can alter the carbon cycle. Okay, so these alterations are contributing to the environmental problems affecting the atmosphere and oceans. Okay, so that is a carbon cycle, and now we go to the nitrogen cycle. So nitrogen cycle basically are the involved in cycling the nitrogen within the ecosystem are the bacteria, okay, and also fungi. So nitrogen gas makes up the 78% of the volume of the atmosphere. Nitrogen cannot be absorbed and used directly as a nutrient by plants or animals, but as a component of compounds such as ammonia or ammonium, and it becomes a plant nutrient. Okay, so nitrogen gas cannot be absorbed directly by plants. Okay, so like for example, if you have a plant there and nitrogen gas is in the atmosphere, which is takes 78% of the volume of the atmosphere, then the nitrogen gas in the atmosphere, the plants cannot absorb it. So it needs to be converted first into ammonia or even ammonium. Okay, but how are the nitrogen gas in the atmosphere can be converted into ammonia or ammonium? Okay, these compounds are created within the nitrogen cycle. Okay, by reactions involving lightning, okay, and also by specialist bacteria that are actually found in the top layer of the soil. Okay, other specialist bacteria convert most of the ammonia or ammonium in the soil to nitrate ions. Okay, so the ammonia and ammonium are also being converted into nitrates by specialized bacteria. Okay, so lightning converts actually nitrogen gas to ammonium. Okay, so if there is a lightning, then nitrogen gas can be converted into ammonia, okay, or even into ammonium by the specialized bacteria. Okay, no, by ammonia or ammonium. Okay, and therefore, and this ammonia and ammonium can be converted into a nitrates by specialized bacteria. So what are these specialized bacteria that are involved in the nitrogen cycle? And there are also processes that are involved within. Okay, so these are the specialized bacteria and their processes in the nitrogen cycle. So the first process in the nitrogen cycle is what we call the nitrogen fixation. Okay, this is actually done by the rhizobium. Okay, rhizobium bacteria. Okay, so rhizobium uh, are actually in the nodules or in roots of the plants. Okay, so it converts the nitrogen in the atmosphere to ammonia, then to ammonium. Okay, and it happens in the nodules that form in the roots of the plants. And after the ammonia and ammonium are present already there, that means it's actually fixated or it's actually fixed by the rhizobium. Then there's what we call the nitrification, and this nitrification are done by the nitrosomonas, where it converts the ammonia or the ammonium into a nitrite ions, and then from nitrite ions it converts into a nitrate ions. It actually further oxidized or further converted into nitrate ions. Okay, from nitrite it is further converted into a nitrate ions. Okay, so this is their process now. From the atmosphere, you have your nitrogen gas. Then, by the action of the rhizobium, it actually fixes the nitrogen, which it converts the nitrogen gas into ammonia or ammonium, then to ammonium by the rhizobium. That is what we call the nitrogen fixation. And after ammonium is converted, or ammonia is already been fixed, or ammonium is fixed in the nodules of the plants, the nitrosomonas bacteria will undergo nitrification, where it converts the ammonia or ammonium into the nitrate ions, and therefore it further converted the nitrite ions into a nitrate ions. Then after nitrification, okay, Pseudomonas can also denitrify the nitrate ions, where the nitrates can be converted back to nitrogen gas, and it goes back to the atmosphere now. Okay, and there is also another process, which is what we call ammonification, where the decomposed tissues, okay, decomposed tissues by fungi releases inorganic nitrogen as ammonia. Okay, so those that are dead bodies or dead tissues can be decomposed, and it actually releases inorganic nitrogen in a form of ammonia. This ammonia can also be converted into nitrite and then to nitrate by nitrosomonas, and the nitrate that is produced will be denitrified by pseudomonas, where the nitrates can be converted back to nitrogen gas. The nitrogen gas will goes back to the atmosphere, and the cycle continues. So this is now the figure that shows the nitrogen cycle. Okay, so we have the nitrogen in the atmosphere can be fixed by the rhizobium. Okay, through the process of nitrogen fixation, where the nitrogen can be fixed, where nitrogen gas can be converted into ammonia or ammonium. Okay, and after that, ammonia and ammonium can be nitrified by what we call the nitrosomonas bacteria, where the ammonia and ammonium can be converted into the nitrite ions and further converted into a nitrate ions. Then nitrate ions can be denitrified by Pseudomonas bacteria, which therefore converted your nitrate ions into a nitrogen. Okay, and the nitrogen gas will be goes back to the atmosphere. Okay, so that's the process there. And also the decomposed tissues of the dead bodies of the animals will in turn be undergoes ammonification, where all of the decomposed tissues which contains nitrogen will be converted into ammonia, and therefore in the process of ammonification. Okay, so those are our source for ammonia. It could be by nitrogen fixation or by rhizobium, or the ammonification because of the decomposition of tissues. And that's it. That is the nitrogen cycle. And how can we alter the nitrogen cycle? So we actually intervene in the nitrogen cycle in several ways, okay? We add large amounts of nitric acid as a product of combustion when we burn gasoline and other fuels. In the atmosphere, nitrogen oxide can be converted to nitrogen dioxide and nitric acid, which can return to the Earth's surface as a damaging acid deposition, commonly called as the acid rain. Okay, and we also alters the nitrogen cycle by removing large amounts of nitrogen from the atmosphere to make ammonia and also ammonium ions, which are used to make fertilizers. Okay, and in addition, we alter the nitrogen cycle in aquatic ecosystem by adding excess nitrates to bodies of water through agricultural runoffs of fertilizers and animal manure, and through discharges from municipal sewage treatment system, which can cause excessive growth of algae that can disrupt the aquatic system. Okay, so these are actually example of the fertilizers. Your fertilizers are actually contains NPK. Okay, so the N there signifies a nitrogen, P there is actually phosphorus, and your K is potassium. Okay, so during agricultural runoff of fertilizers, we are actually uh, we are actually uh, we are actually adding excess, okay, nitrogens in a form of nitrates in the uh, in the in the aquatic systems, okay, because of agricultural runoff. Okay, now let's move to the phosphorus cycle. So phosphorus cycles, so the compounds of phosphorus circulate through water and the Earth's crust and living organisms in the phosphorus cycle. So most of these compounds contain phosphate ions, which is actually an important plant nutrient. And phosphorus does not recycle through atmosphere, and its cycle is slow compared to the cycling of water, carbon, and nitrogen. Okay, so the phosphorus cycle is very slow compared to water, carbon, and nitrogen. So as water runs over exposed rock, it slowly erodes away inorganic compounds that contain phosphate ions. Okay, so as the water runs, okay, as the water runs or run off, you have water runoffs, okay, it slowly erodes away inorganic compounds that contain phosphate ions and carry these ions into the soil, where they can be absorbed by the roots of the plants, by other producers, or phosphate compounds. Phosphate compounds are then transferred by food webs through producers to consumers and eventually to detritus feeders and also decomposers. Okay, so phosphates that are actually found in mining waste or even on the fertilizer can be run off, okay, and will be eroded, uh, and therefore it could be absorbed by the plants, which in turn will be used up by the plants, and therefore the plants will be consumed by those consumers, okay, and therefore the phosphorus now can be transferred from plants to the animals. And from the animals, when the animals dies also, the detritus feeders will now be responsible for the decomposition of the tissues, which can produce phosphorus. Okay, and this phosphorus now would also be used up, okay, and will also be carried out during surface runoff, and will be again be used up by the plants in a form of phosphate, and the cycle also continues. Okay, so phosphate can be lost from the cycle for long periods of times when it's actually washed in the ocean, where it is typically deposited as marine sediments. Okay, so your phosphorus can be this phosphorus cycle can stop when it's actually being washed into the ocean, where it is deposited as a marine sediment and can retain trap for millions of years. So you notice that here in the cycles, okay, so when it is found in already in the deep ocean sediment, so it can be trapped there over millions of years. And over time, geological process can uplift and expose the steeper deposits from which phosphate can be eroded. Okay, if there are plate tectonics or there are actually geological processes, so this can be altered. Okay, and therefore a phosphate can be eroded and freed up to re-enter the phosphorus cycle again in the form of phosphate. And because most soils contain little phosphate, the lack of it often limits plant growth and on land unless phosphorus is applied to the soil as a fertilizer. So remember, the fertilizer that we use is actually has a phosphorus in it. Okay? So lack of phosphorus also limits the growth of producer populations. In many freshwater streams and lakes, because phosphate salts are only slightly soluble in water, thus do not release many phosphate ions to producers in aquatic systems. Okay? So phosphate salts are slightly soluble in water, so therefore it cannot be absorbed by some of the aquatic producers, okay, or in the aquatic systems. Okay, so they cannot use up the phosphorus. Okay, those producers that are actually found in the aquatic system. And human activities, including the removal of large amounts of phosphate from the earth to make fertilizers. Okay, so this is now how we alter the phosphorus cycle when we remove large amount of phosphate to make fertilizers. That is one way that we can alter the phosphorus cycle. And also by clearing tropical forests, we reduce phosphate levels in tropical forests and topsoil that is eroded from and fertilizer that is washed from fertilized crops uh, that is fertilized crop fields, lawns, and golf courses carry large quantities of phosphate ions into streams, lakes, and oceans, and there they stimulate the growth of producers such as algae and various aquatic plants, which can upset the chemical cycling and other processes in the bodies of water. So all of these nutrients like the nitrogen and the phosphorus, when they are actually in large amounts when in their large amounts and they're actually run off and goes into the streams of lakes and oceans, the algae will eventually uh, will stimulate its growth and increase its number, and that is what we call the algal bloom. So they stimulate the algal bloom if there are large amounts of phosphorus and nitrogen in that aquatic system or in that water or in that streams, in that lakes or in that ocean. Okay, so if we are going to use a large amount of fertilizers and therefore this can be cause agricultural runoff where it goes to the streams, lakes, and oceans, and therefore it can exhibit or it can manifest the growth of the algae, and in turn it is what we call now the algal bloom. Okay, so that's the phosphorus cycle. So now let's move to the, I think this is the last one already, which is what we call the sulfur cycle. Okay, sulfur circulates through the biosphere in the sulfur cycle. Much of the Earth's sulfur is stored underground in rocks and minerals and in the forms of sulfates. Okay, so buried deep under the ocean sediment. Okay, for phosphorus, it should be converted into phosphate first in order for it to be absorbed by the plants and to be used up by other uh, other living organisms. Okay, and also in sulfur cycle, it should be sulfur should be converted into sulfate first. Okay, sulfur enters into the atmosphere and from several natural resources. Like for example, you have your hydrogen sulfide, which is actually the one that is actually the gas that emits by some volcanic vents. Okay, the one that we have in the Pulang Bato. Okay, when you travel there in the Valencia at the Pulang Bato, so the smoke mountain there, okay, that actually releases gas that is have a rotten egg smell that is colorless. Okay, that is actually hydrogen sulfide. So hydrogen sulfide, okay, is actually released from active volcanoes and from organic matter broken down by anaerobic decomposers in flooded swamps, bogs, and tidal floods. Okay, and hydrogen sulfides are smell like a rotten egg. They are colorless and also they are poisonous gas, which actually release from active volcanoes. Other sulfur containing compounds that are released in the environment is also sulfur dioxide. Okay, so sulfur dioxide is actually colorless and it's a suffocating gas, which are actually also released from volcanoes. Okay, so particles of sulfates, salts such as ammonium sulfate enter the atmosphere from sea spray, dust storms, and forest fires. Plant roots absorb sulfate ions and incorporate the sulfur as an essential component of many proteins. Okay, so plants can be able to absorb sulfate, okay, ions which are actually used for their protein components. Okay, so in the oxygen deficient environment of flooded soils, freshwater wetlands, and tidal floods, specialist bacteria are also able to convert sulfate ions into sulfides. Okay, and the sulfide ions can then reacts with metal to form a metal sulfides and are deposited as rocks or metal ores. Okay, so sulfate can be converted into sulfides by sulfate reducing bacteria, and these sulfides now will react with metals to form metal sulfides, and they are actually deposited as rocks or metal ores. They are actually often extracted by mining and converted to various metals, and the cycle continues. Okay, human activities can, so this is now the picture of the sulfur cycle. Okay, so sulfur dioxide is actually the primary main component that is actually found in the atmosphere. Okay, because sulfur itself is not a gas, but rather it's a solid. Okay, but once it is in the form of sulfur dioxide, then it's actually a gas. So our main sources for sulfur dioxide could be volcanoes. Okay, so that is our main sources, and other when we burn fossil fuels, it also produces sulfur dioxide. Smelting and burning coal can also produce sulfur dioxide. Okay, so that's it. And sulfur can goes back to the surface in the Earth's surface because of acid rain. Okay, so sulfur can be mixed with your water vapor, and therefore sulfur dioxide plus a water vapor could create a sulfuric acid. Okay, in a form of an acid rain, and therefore has a negative effects or detrimental effects on the living organisms as well as also in non-living organisms that are found on the Earth's surface. Okay, so human activities can have an effect on the sulfur cycle, primarily by releasing large amounts of sulfur dioxide into the atmosphere. Okay, we release sulfur to the atmosphere in three ways. First, by burning sulfur-containing coal and oil to produce electric power. So that is also one way that we can enhance the amount of sulfur dioxide into the atmosphere. Second, when we refine sulfur-containing oil, which actually can create petroleum to make gasoline, okay, heating oil and other useful products. And third is we extract metals. This is actually in mining industry now. We extract metals such as copper, lead, and zinc from sulfur-containing compounds in rocks.